Alright, today I'm going to show you a little bit of how to make solutions. We looked at this in class the other day, but I thought maybe a video lesson would help out a little bit. What I'm going to do here is going to create a 100 milliliter solution of 6.0 molar aluminum chloride. Okay. Keep in mind that aluminum chloride has 3 chlorine ions in here. I'm going to talk about that at the very end just to make sure everybody's okay with understanding how to read ionic compounds in solution. Alright, so what I have here is what's called a volumetric flask. And volumetric flasks have one single mark on them. So they're not like graduated cylinders where they have a whole bunch of marks on them. Volumetric flasks only have a single mark. And this one is going to be at the 100 milliliter mark. Okay, our next lab that we're going to do, you guys are actually be working with these and creating solutions. So it's a really important video to watch. Alright, now aluminum chloride is a solid substance at room temperature. Most ionic compounds are going to be solids. So to make this solution, I have to measure out the mass of solid that I'm going to need. Okay, so that's what I'm going to need here. So in order to make this solution, what I'm going to do is I'm going to add some solid material to this, the aluminum chloride, and then dilute it with water until I get to this mark. Okay, so the first thing I need to know is what's the mass of the solid that I need. Well, I'm going to use this here, which is volume, and my molarity. Remember I told you that molarity is moles over volume. Right? Since this is volume and molarity, if I multiply these two together, it's going to tell me how many moles I need. Well, if I know how many moles I need, then I'll know the mass. Okay, so again, the connecting piece between these two is the mole. Okay, so the first thing to do is get rid of the milliliters and convert that to liters. So I'm going to have 0.100 liters, and I'm going to go ahead and get rid of the volume by putting my moles at the top, which is your molarity. So this is my molarity right here. So I'll put 6.0 over 1. What this would do is it will give me my number of moles of substance, which of course if we do the calculation would be 0.600 moles of aluminum chloride. So that is the number of moles that I want to put in this container that I'm going to have in the solution. Okay? Alright, so if I'm going to figure out how many moles that is, I'm going to have to figure out the mass. So 0.600 moles of aluminum chloride, and I just used the molar mass of aluminum chloride. And again, if you haven't done so, download or install an iPhone app or an Android app. I use Chemistry Helper on my HTC Android, so I'd recommend you do that. It makes things a lot faster for molar masses. Alright, so that's the molar mass of aluminum chloride. And if I do that calculation, I end up with about 80 grams of aluminum chloride. Okay, so that's how much aluminum chloride that I need to have in the container. So what I would do is I would take this mass and I would measure it on a balance, and I would put that solid stuff in here. So what I would put in here is 80 grams of aluminum chloride. I want to make sure those dots look really good. Okay, so aluminum chloride. Then what I have to do is I have to get myself some water and pour some water into here. Okay, so H2O then goes in, and I dilute it up to this point. So now I've got water in here. So now it's all wet, and I end up with a solution. So there you go. Mixture is now made, or solution is now made. And that would be my aluminum chloride solution. Okay? Alright, so that's making a solution from a solid. Now I'll show you how to make a solution from another solution. Okay, so I have this 100 milliliter solution of aluminum chloride that I previously made. So this is now what's called a stock solution. And what a stock solution means is that I know exactly what the molarity is because I previously made the solution. And this is a stock solution, so it's a higher concentration. So what I'm going to do is I'm going to make smaller solutions from this batch. So here what I'm going to do is I'm going to make a 200 milliliter solution of 2.5 molar aluminum chloride. Okay, so for a particular lab, I'm going to take this large portion and I'm going to make a smaller portion. Now it looks misleading because it says 200 milliliters, but I only have 100 milliliters. Well, it's because this is more concentrated. I'm going to dilute it down to a lower concentration. So what I need to figure out is how much of this I'm going to pour into my container. So I'm going to need another container, and that other container would be a 200 milliliter container. And again, this is a volumetric flask, 200 milliliters. And what I'm going to do is I'm going to go ahead and make my solution in this container. So now, since I already have a solution made, what I have to do is I have to pour this solution into this container. The question is, what volume do I pour out? Okay, so I'm going to use this solution. Now this 100 milliliters isn't really that important here for this problem, so don't be misled by that. This is the volume that I'm really focusing on because I'm not going to use all 100 milliliters. The question is, how much of this am I going to use to put in this container? Okay, so to do that, again, it's all about moles. When I pour a solution, what I'm doing is I'm going to be pouring the moles of material from one container to another. So as I pour a volume out of this, a little piece of the solution goes into the container over here, and therefore I'm pouring the aluminum chloride with it. So I can count my moles by multiplying my molarity by my volume. So over here I know that I want this to be 2.5 molar aluminum chloride solution. So therefore this right here tells me how many moles that I actually want. Right? Okay, so if I take that 200 milliliters, I can figure out how many moles by multiplying it by the molarity. So 0.200 liters, and then multiply that by the molarity again, 2.5 moles over liters, and that will give me my number that I need, which is essentially going to be, what is it, 5.0? Or 0.5, I think it's 0.5 now that I think about it. 2.5 times 0.2, of course, it should be, yeah, that's what I thought, 0.5. Okay, so this is 0.500 moles. So that's really the number of moles that I want to have in this flask here. Okay, where are those moles going to come from? They're going to come from my stock solution. So now I take these moles that I know in the molarity and I find the volume. So my volume is what I'm looking for here. And so what I can do is I can say, okay, I got 0.500 moles. What I want to do is get rid of the moles this time and multiply that by, well, the volume on top. So 1 liter, 6 on the bottom. So I'm just going to divide that by 6. And I end up with 0.08333 liters, or 83.3 liters of the 6 molar solution of aluminum chloride. So what that means is I need to pour into my container here, I need to pour in 83.3 milliliters. Okay, when I do that, that'd probably be a little bit higher, wouldn't it? Okay, let's move it up a little bit. Okay, let's just say it would be like right around here. Okay, so this would be my 83.3 milliliters. Okay, now what I have to add is water. So water now has to go inside of this container. And I would go ahead and add water until I got to this mark right here. So the water that I would add, which would be the rest of the solution here, would be the 200 milliliters minus 83.3 milliliters, which is about 16, what was it, 116.67 or so milliliters. So about 116.7 milliliters of H2O. So that's how much water I would have to add to bring this up to a total volume of 200 milliliters. So again, I'm taking this concentrated solution and I'm diluting it down by adding the water to it. Okay, I'm making my final solution 200. So I'm backing it up and going backwards for moles. Now, what you could do with this problem is you can actually do this a different way, and you probably already remember this, hopefully, which is using M1, V1, and I'll show you how to do that right now. Okay, so I can do this problem really quick if I understand how to use the dilution equation. And that's M1 V1 equals M2 V2. And the reason why this works is because I'm multiplying molarity by the volume, which is really moles of 1 is equal to the moles of 2. If you think about what I did in that last problem, I came over here and I calculated mole 1, and I used that same mole 1 in my first part over here, which was for moles 2. So that's the origin of the equation. So if I'm solving for V2, this would be my V2 right here. And this would be my M2. Over here would be the volume 1, and this would be my molarity 1. Okay? So if I'm solving for V2, it's going to be M1 V1 over M2. What's nice about this is that I can use my molarity, 2.5, and I don't have to change my volume to milliliters. The reason is that the molarities are going to cancel out. I'm going to bring this 6 over here. So these will cancel out, and I'll end up with my answer directly in milliliters. It would be 83.3 milliliters of 6 molar aluminum chloride. Okay? And that's a quick way to calculate that. Now, one real quick thing about the solution here. Keep in mind when you're dealing with this that the moles of chloride are going to be triple the amount in here. So if this is 2.5 molar aluminum chloride solution now, the chloride ions are going to be triple that amount. So make sure that if they ask you what the concentration of chloride ions were, that you would do 3 times 2.5 molar. And that would be your concentration of chloride ions. While your aluminum ones would be the same value because it's a 1-to-1 ratio. So there's your little video on how to make solutions. I hope it helps. Thanks.